Welcome back, Calculus. Let's see how we did on these ones. So for part A, let's take the integral of 2x times x squared plus 1 to the fourth. I'm going to call u x squared plus 1 because that derivative is just the 2x dx. So the 2x dx is the derivative of what's in the inside. So this is just going to be the integral of u to the fourth du, which is 1/5 u to the fifth plus c. And then just replace the u. With x squared plus 1. So that's what I got for A. And again, if you take the derivative, you go back to where you started. Oh, wait, that's a 5. Yeah, so this is just 1/5 x to the fifth. Let's look at B. So the antiderivative of the x cubed is the 3x squared, which I see out in front. So I think this is just going to be like taking the integral of the square root of u. So if I take u to be x cubed plus 1, the derivative of u would be 3x squared dx. So I can rewrite this as the integral of, let's see, that's going to be the square root of u, which is u to the 1/2. So u to the 1/2. And the 3x dx is the du. That's u. So yeah, use that power rule. That's going to be 1/2 plus 1 is 3/2. U to the 3/2 over 3/2. Dividing by 3/2 the same thing as multiplying by 2/3. So I get 2/3 x cubed plus 1 to the 3/2 plus some constant. And part C. This one I'm going to have to look at my chart. I believe the derivative of tangent is secant squared. So let's take u to be the tangent x plus 3. The derivative of that would be, yep, secant squared x. So this one will be a little not so bad. So that's my u. And that part right there is my du. And that's just going to be 1/2 u to the second plus c. Oop. 1/2 u to the second plus c, which is 1/2 tangent x plus 3 to the second. All right, so those ones the du's were just right there. The 2x dx was right there. The 3x squared dx was right there. The secant squared dx was right there. These next three integrals are similar to the first three, so we're gonna have to multiply or divide by a constant so that we can evaluate them. I'll try to squeeze it in here. Let's do Christmas colors. All right. And we'll make them a little skinnier. Okay. So the integral, so I'll do that one. We'll do that one after that. And we'll do this one after that. These ones are going to be very similar. There's going to be one kind of like extra thing we're going to have to do. So the derivative of x squared is 2x, not x, but we can get rid of that 2 no problem. So let me just call u to be x squared plus 1. The derivative of u would be 2x dx. So 1/2 du would just be the x dx. So now I got that taken care of, and that's my u. So we can just rewrite this as the integral of u to the fourth. The x dx is 1/2 du, so I'll put the 1/2 here. And let's do that. This is going to be So I'm going to have 1/2 u to the 5th over 5 plus some constant, which is going to be 1/10 u to the 5th plus c, and again u is x squared plus 1. Here, still going to take u to be x cubed plus 1, and du is going to be 3x squared dx. I just don't want that 3 because there's no 3 there, so I'm just going to rewrite this as 1/3 du equals x squared dx. And then we got our integral, the square root of u du, and so the x squared dx is 1/3 du, so I need that 1/3 here. And remember, the square root of u is the same thing as u to the 1/2. So this is going to be 1/3 u to the 3/2 times 2/3 plus c. So let's see, that's going to be 2/9. U is x cubed plus 1 to the 3/2 plus c. Okay. Let's write that a little neater. X cubed plus 1. Okay. Last one, we'll do the same thing. If I take u to be tangent x plus 3, the derivative of that would be secant squared. And if I just multiply both sides by 2, then we got our 2 secant squared x. Simple enough. So this is going to be the integral of, let me see, that right there is going to be u. This part right here is going to be 2 du. And then from here, let's go 2u squared over 2 plus c. And I believe the 2's will cancel out. And I'm going to get u squared plus c. And u again is tangent x plus 3. So see how you did on those. We'll do a couple more examples and then maybe some practice problems for homework.